The next speaker is my co-chair, Peter Dueck, a graduate of U of S, University of Saskatoon, or Saskatchewan. He then kind of went over to the dark side. He ended up in the oil and gas for a while. But he came to his senses and got a job with Cameco and worked there for a few years. And about 3 years ago, he moved to Flin Flon. And actually convinced his wife that they have a great future in Flin Flon, and now he's chief geophysicist of Hudbay. So and the talk is called, and the co-authors is Alan Vowels and Peter Dueck, and the talk is historical setting and exploration in the Chisel Basin, Snow Lake.
Yeah, as much as I tell my wife that Flin Flon's a promised land, she hasn't quite 100% bought into it yet. As for the co-author, Alan basically, he should be the one giving this presentation. It's kind of a historical setting, and he knows it all. He's sitting beside, Dan McKechnie and Jim Pickell and Dave Coop, and they've got tons and tons of stories. So if you can clear, 6 or 7 hours out of your calendar, I suggest you talk to them. So just to give you a quick snapshot around 2002, Dave Coop will be talking later, and he's put a lot of time and effort into creating a picture of what happened before 2002, how Bob Fraser was involved, a lot of the exploration stuff. So again, I really encourage you to talk to Dave. He's done a lot of really good work on that. But in 2002, Hudbay, or Hudson Bay Exploration and Development, which is our exploration group, identified the Chisel Basin as high potential for discovery. So they knew the Chisel stratigraphy was favorable and was getting progressively deeper. So a task was given to the geophysics group and again to Alan to basically how can they explore at greater depths. So at that time, Crone Geophysics just developed their high-speed receiver. So Hudbay had, I don't want to use a term, a slow speed, but a first-generation receiver, let's call it. And so this new high-speed receiver was capable of collecting higher quality data in a significantly shorter amount of time. So the first task that Alan had to basically accomplish was to convince management that we needed, or Hudbay needed to buy this high-speed receiver. So the test was fairly simple. The Chisel North lenses are somewhere approximately 600 meters below surface. So if these lenses could be imaged with confidence, then Alan was allowed to basically buy this new receiver. So this was a strategic step in testing new and future technologies. I'd like to bring this, make a little emphasis at this point because I asked Alan, Hudbay is unique where we actually own our own geophysical equipment. We own surface equipment, we own borehole equipment, time domain stuff mainly, where a lot of other mining and production companies don't own that stuff. I asked Alan how important it was. He didn't say anything. He just held his arms open like this. I think one of the real advantages that Hudbay's had over the years is we've been able to do our own testing, try different things. Alan's got many stories where, people told him in theory it's just not going to work. Alan gets out there and gets his boots on the ground and finds out, surprisingly, it works, and it works very well. So I think that's one of the real advantages Hudbay had in previous decades was that since we owned our own equipment, we could actually do a lot of this testing, and to Alan's credit, no was not necessarily an answer, So the first test was on CH9305 Wedge 2, and it intersected the Chisel Basin stratigraphy at almost a vertical depth of about 1,100 meters. So you can see that by the in-hole response there shown in the plots. So the Crone Z probe, which is their borehole probe, could see that right from surface. So this proved the concept that time domain EM, how we were doing it, could see these conductors at a significant depth. One point to make, I was kind of going through this some of these slides with our junior geophysicists in our group. I had to plot that up using Excel. I can't imagine what some of the seasoned explorationists had to do back in the day, plotting things by hand. It makes it fairly easy to see. Now with software, we can rescale, we can resize, we can do whatever we want with the click of a button. Where back when they were doing this exploration, everything was plotted by hand. So subtle anomalies obviously and easily could have been missed, that even taking the data that was collected back a decade ago, I'm sure there's things that just with plotting routines, you could probably find extra things in data that's already been collected. So again, it was decided to do a test with the Generation 1 Crone receiver over the deepest part of the Chisel North mine. So a survey was designed basically to mimic the capabilities of the new high-speed receiver. So what they did was they set up the station and they collected over 16,000 stacks. From my understanding, a lot of people didn't understand how Dave and Alan had jobs, because they'd let it take a reading, they'd go have lunch, and then they'd come back. It took so long. So, don't let anybody tell you that's what geophysics is. It's not that easy, just for Alan and Dave. So the test was successful. You can see the different decays on the slide. So it basically showed a clean decay. And so this confirmed that there was a secondary field present at measurable at depth. So this basically proved the concept and proved that the EM was going to work for us. So I have just a few slides here that's pre-2007, and I'm using it more as in pre-Lawler discovery. So you can see here the Lawler is the main outline there, and all the other red dots are either mines or zones or deposits. These are all and this is not a comprehensive list. Dave Coop brought to my attention after the fact. I had this slide made. He found other grids that his brother actually collected right directly over Lawler as well. But when you take a first look at this, if you look at a plan map, you'd say, well, this is not necessarily adequately explored, but you could almost say it's overly explored. So when you take a look at the different types of surveys, and I'm not going to go into this, I'm going to assume that most people will know this. If not, you can ask me or ask somebody else. But you have TURAM, VLF, HLEM, fixed loop, moving loop. And all these surveys were actually, whether it's just the physics or the parameters used, were actually too shallow to image Lawler. So, for example, like fixed loop or moving loop, which are very applicable today to seeing at these depths, but they were using low power transmitters, high frequencies collecting the data, or receiver transmitter separations of hundreds of meters instead of the stuff that we need. So it's interesting to say that there was geophysical surveys done over Lawler, but yet it was impossible to detect Lawler at that depth. So here's drill holes that are less than 500 meters. So, just making a very rough assumption, say Lawler sits at 600 meters. So again, a lot of the drilling obviously was focused around known mines and deposits and zones. But again, very little deep drilling. And when you take the holes over 500 meters, you see that basically they're kind of focused around Photo and Chisel North and the Penn Zone. But so even with all the drilling in geology, it's just the point, it'd be difficult, if not impossible, to find Lawler with, say, the pre-2007 work. So in conclusion, the Chisel Basin hosts many VMS deposits. So again, decades of historical geophysics, but none would have been able to detect the Lawler mine. Majority of drilling was situated over historical deposits. And this is the real point that I'd like to hit home, and I hope everybody sees that, is that, again, with GIS capabilities now, you can put everything on a plan map, and like I said, it could look overly explored. But it doesn't necessarily mean it's adequately explored for the targets that you're interested in. Whether it's depth, I'm 100% confident that if you had a mine the size of Lawler sitting at 100, 200 meters in that area, sure, you would have found it. But I think in the camps and these areas that everyone's doing exploration in, just because it's overly explored, I don't think it means it's adequately explored. I've also asked Alan, some of his lessons learned, and he's mentioned many times, even in the last year working with Alan and our group, we've made a lot of I think really good steps forward in our understanding of VMS deposits and how to find these, and this is literally just in the last year, maybe two. So you ask Alan, if we would have known what we know today 20 years ago, how many would you have found? And the same question goes in the next decade. If you'd know what you know 10 years from now, how many would you have found today? So some of these areas that have been previously written off, I don't think are necessarily written off for all time. That again, that there could be stuff lurking there, that technology evolves, geological theories evolve, and some of this stuff deserves to be revisited. So, yeah, questions? You know, Craig or Alan can mention or talk to that a lot better than I can. I don't know, Craig, if you want to.
Well, it was an anomaly that was on the books since, was it 2002 or 2003 the survey was done, Alan?
The survey was done in 2003. The testing was done in 2002. Yeah.
So it was on the books and as basically timing on the exploration programs to get that anomaly tested.
Management always thought that, or exploration thought there was potential depth. But it's just with management to look beyond 500 meters.
No, it's more just priorities. At that time, we were drilling on the Bird deposit, which we were looking at putting into production, so we had a lot of resources concentrated on that and other anomalies in the area, so it was just timing.
So I believe I've heard Craig say before is that, you know, it was scheduled to be drilled and it was supposed to be drilled in 2006 or something, but then they had exploration programs elsewhere, and then just with early breakups, whatever, it couldn't get drilled that year, and then finally, I believe in 2007, all the stars aligned and that they could drill that first hole.
In 2005, we drilled holes around the other known mines in the area, Chisel North area. 2006, we planned to drill this anomaly, but couldn't because the snow was too deep. Spring came, like Peter said, so.
So this was just a pure geophysical anomaly. There was no geological concept, no geochemistry, nothing really close by in terms of drilling.
There was one drill hole, about 500 meters to the east, Alan, at Dub 33.
Yeah, that was the closest one.
So that hole showed we had the right geology.
Right. Was
So
this
showed the
sodium
alteration, but this was a geophysical target
Right.
in that right geological environment.
We heard some about sodium depletion as being a big envelope in the area. Was that information available?
It was from that Dub 33 hole,
Okay.
but again, it didn't help target that specific spot. That specific spot was based on the geophysics.
Can I ask a question? What were you thinking when you were looking at this big, huge anomaly? What did you think it was? I mean, you waited quite a few years before you finally popped a hole in it. What was going through the minds of Hudbay at the time? Were you thinking it is an ore body? Wow, it's got to be an ore body? Or were you thinking, oh, that's probably, I don't know, whatever?
Well, it wasn't that clear, this is an ore body. It would have been drilled in 2003. At 2003, Alan, I guess you tested the other anomaly to the south?
Yeah. Well, in 2003, we tested the first one, and it was at that point that when we didn't hit ore, it was sub-ore grade. They were only given one hole to drill, and there was essentially no further budget. And you could drill a hole virtually anywhere in the Chisel Basin and come up with some values. And it was a hard sell to drill 1,000
Well, if anybody else has any more questions, I can delegate to Alan or Craig. That's great.
All right, thank you, Peter. So, we finished a bit early.